Hi, I'm Simon Das and I'll be demonstrating the data management capabilities of the 3DEXPERIENCE platform and the benefits they can bring. As businesses are forced to be more innovative to remain competitive, they will face and have to overcome many challenges to foster that innovation. Whether you're a new startup or an established business, in today's world, working remotely in dispersed teams is more vital than ever, and making this happen brings its own IT hurdles. On top of that, working collaboratively with your team on many kinds of documents and design data can also be difficult, especially when the data and people are not located together. And completing the design phase is just the beginning of the product's life, so being able to share information downstream is as important as ever. The 3DEXPERIENCE platform allows you to securely centralize your data, improve collaboration, and design concurrently, all in the cloud, while maintaining our design tool of choice, SOLIDWORKS. Connected to the platform, SOLIDWORKS is always in sync, and with the seamless integration, you can store and manage SOLIDWORKS data in the cloud, enabling collaborative working wherever you are. As a bit of background info, you access functionality in the 3DEXPERIENCE platform based on roles. These roles provide apps aligned with job functions like design, governance, manufacturing, and more. For example, the Collaborative Business Innovator role provides apps for cloud file storage, social elements, viewing, and many more, all accessed through the user-defined web dashboards. The Collaborative Industry Innovator role adds apps for engineering teams needing deeper data management capabilities like vaulting, lifecycle, and viewer markup tools. And the Collaborative Designer for SOLIDWORKS role provides the connectors to allow seamless integration between CAD and the 3DEXPERIENCE platform. This demo centers around this garden sprinkler. A change needs to be made to stabilize and stiffen the design, so a small team needs to work collaboratively to make that change happen. Let's follow a project leader and a design engineer to see what it looks like to store and manage SOLIDWORKS data in the cloud, and how they collaborate during the design process. The process starts with the project leader creating and assigning a task for the design change to the design engineer. The design engineer then uses the task to start the design work and then notify the project leader when he's done. Next, the project leader will review the changes in the platform and sign off on the new design. Finally, the design engineer completes the process and releases the design. In the first demo, we will use the project leader's perspective to show the web-based user experience of the platform, how tasks are created, and how an enterprise user of the platform can view CAD models. Let's start by logging into the 3DEXPERIENCE platform as the project leader. Once logged in, the platform presents the project leader dashboard. It contains two tabs, the to-do list and design review tabs, two functions important to the project leader job. The design review tab contains two apps or widgets, one for bookmarks and the other for 3D markups. The to-do list tab also contains two apps, one for managing tasks and the other for viewing product structures. Multiple dashboards can be set up and switched between, depending on what's required. Apps can be added to dashboards from the 3DEXPERIENCE compass. This shows the roles assigned to your login and many associated apps. These are all the apps included with the three roles mentioned earlier. In the To-Do List tab, the project leader will create a new collaborative task. This will be given a name and instructions added. The new task will allow the project leader and a design engineer to collaborate on a design change. To focus on the new task, the app window will be maximized. The design change needs to make the sprinkler more stable in use. The project leader can set the maturity state of the task. Changing it from draft to do will make it visible to the assignee. An estimated completion date can be set, and the design engineer quickly assigned to the task by typing their name. As SOLIDWORKS CAD data needs to be modified, it can also be attached as an attachment by searching for a partial name and then selecting the found orbital sprinkler assembly with the default configuration. Once the task is saved, the design engineer will be notified in the platform, but also by email. Before the project leader is done, he can take a quick look at the orbital sprinkler assembly. This is simply achieved by dragging and dropping the attachment from the task into the Product Structure Explorer app. This loads a lightweight 3D representation of the CAD model in the app, all in the web browser, without the need to install any software. Let's summarize what was shown in the benefits. We saw the easy web-based access of the platform, making it available anywhere on any device. We saw how to create a task for a new design, and the simple and effective Kanban-style task management. And we saw how non-designers can view CAD data in the web without having to install anything. In this second demo, we will use a design engineer's perspective to pick up the task from the project leader and show the 3D experience integration in SOLIDWORKS, how design revisions and maturity states are controlled, and how to organize data using bookmarks. The design engineer opens up his email and he can see he's received a notification from the platform. He can have a quick view of the information input into the task, and he can see that the task needs to be completed by a certain date. Switching to SOLIDWORKS, the design engineer can access all his tasks directly through the 3DEXPERIENCE integration. Using the compass, we see all the roles and apps available. With the Collaborative Tasks app, I can see all the assigned tasks in a Kanban-style layout, starting with the to-do list. The task for the sprinkler design can be expanded and the details reviewed easily. The SOLIDWORKS model attached to the task can be opened. The integration even allows the selection of how to load the model. During the opening process, the SOLIDWORKS files are downloaded from the cloud and cached locally on the PC. Once open, we can drag and drop the task to the In Work column to indicate to the project leader that the work has begun. Switching to the My Session option in the integration shows the assembly structure. This also enables the action bar at the bottom of the pane, providing PLM functionality within SOLIDWORKS. Before modifying the base, we need to check to see if it's used in other assemblies, in addition to this orbital sprinkler assembly. This can be done using the related objects in the Tools tab of the action bar. The related object shows that the base is only used in the original design, but I can still expand out the children to see if anything else is linked. The base cannot be modified currently as it's released, so we need to create a new revision to modify it. The modification is being made to the base sprinkler part. This means that both the base and the orbital sprinkler assemblies will also need to be updated. After multi-selecting the components, I'll then click New Revision on the Lifecycle tab, and the New Revision dialog appears. I'll confirm the operation by clicking the Revise button. New revision was created in the platform. The plus sign in the Is Latest Revision column shows that a more recent version exists in the platform. We need to get the new revision from the platform, so the top level assembly is selected and I use a Replace by Revision command. The Replace by Revision dialog appears. Revision B of the orbital sprinkler is in the In Work status and can be modified, so let's select that revision. Once new revisions are loaded, I need to make changes to the assemblies and part, but they have to be reserved or locked first. Selecting the Revision B models, I right-click and reserve them. The reservation column shows an icon of a green key, signifying the files are reserved or locked. This indicates to the enterprise that the changes are being made to those models. The components become read-only for others when reserved by you. Now let's make the design change. It's been determined that adding a fillet to the base will add enough material to stiffen the design. After making the change, we save and close the part, and then return back to the assembly. Remember, the files were cached locally, so the SOLIDWORKS save only affects the local files. The status icons in the 3DEXPERIENCE tab indicate the files have changed since the last save to the platform, so let's right-click and save to the platform. The Save to 3D Experience window allows you to confirm what you want to save to the platform. It also allows you to uncheck any files that you do not want to save. While saving, you can choose to organize the data using bookmarks, making it easier to find later. I click on the bookmark icon in the upper right corner of the Save dialog, and then browse to the bookmark location. Bookmarks can be accessed from within SOLIDWORKS and the web browser dashboard. We'll look at both ways shortly. During the save operation, a 3D lightweight representation plus a thumbnail image is created for each SOLIDWORKS model and configuration. The 3D lightweight representation is used to view models on the platform. Optionally, neutral file formats like PDF and STEP can also be created on save, as in this case. These neutral files can be used for downstream operations where sharing the native data is not appropriate. The new sprinkler and the modified files are now saved to the platform, but the files are still reserved. They could have been unreserved during the save by checking the Release Reservation After Save checkbox, but I'll select the files and right-click and run reserve. I now need to change the life cycle of the updated files from in work to frozen. This would indicate to enterprise users that the files are ready to be reviewed. Selecting the files, I can right-click and change the maturity. No changes can be made to an object in the frozen state. Before completing the task, I want to add some additional documents to the platform. As mentioned earlier, we can use bookmarks to help organize the data. Clicking the compass in the task pane, I locate and start the Bookmark Editor app. Once the bookmark editor loads, I can navigate to the desired bookmark. I can see the sprinkler model listed, and so will anyone else using this bookmark. From the action bar at the bottom of the pane, I'll add some documents to the platform. The Add Document command opens the browser dialog to an external location. Let's select the two files, a PDF and a JPEG image, and get them added to this bookmark location in the platform. The 3D Experience platform can be used to store and manage all kinds of documents related to design, not just CAD files. Now the documents are added, the design engineer needs to complete the collaborative task. Before completing it, I switch to the Comments tab of the open task. I add the note, but also @mention the project leader, so they get a notification of the comment. After closing the panel, a drag and drop of the task to the completed column completes the task, and the model can be closed. Let's summarize what was shown in the benefits. With the 3D Experience integration in SOLIDWORKS, you can quickly access task and CAD data and manage a task with simple drag and drop actions. For the design change, you have easy revision and lifecycle tools, which are aided by visualizing the related data. And organizing data using bookmarks can improve sharing of all types of design information, CAD and non-CAD. In this third demo, we'll see how the project leader will review and validate the work done by the design engineer, compare the revision changes, and then how to search for data when creating tasks to release the design. The project leader selects the Design Review tab from the dashboard in the 3D Experience platform. We'll use the bookmark editor and browse the orbital sprinkler model, and then drag and drop the new revision into the 3D markup app. Once the model is loaded, we want to capture new markups as part of the design review. On the action bar, the markup command is used to start the process. I'll accept the default name, but will add a description. In the 3D markup app, slides are used to save markups, allowing multiple views to be captured. Slides represent an alternative view of the assembly and can contain annotations, sections, and measurements. Let's add a text callout to provide some feedback to the design engineer about a potential future improvement. Let's capture more feedback with another slide. All the slides are shown on the left side of the app window. I'll select and hide the top of the assembly, leaving just the bottom part visible. After zooming in, I'll add another text callout on the fillet added to the new revision. This markup file is constantly saved to the platform, and the platform maintains a relation between the model and the markup file. Just to make sure the current view is captured, I'll update the slide. Switching between the slides is as simple as double-clicking. When finished, we can remove the model from the 3D Markup app and restore the window back. The project leader can perform another check as part of the review process by comparing the assembly structures of the old and new revisions. A drag and drop of the sprinkler loads it into the Product Structure Explorer app. After navigating to and selecting the base subassembly, the Compare app can be opened from the 3DEXPERIENCE compass. This will load the base subassembly into the Compare app, allowing Revision B to be compared to Revision A. This powerful tool visually highlights any changes between the revisions of the design in both the structure and in 3D. The colors assigned show what's identical, what's changed, and new revisions. Let's close the Compare tool and then create a collaborative task to get Revision B released by the design engineer. After creating the task, clear instructions to release the assembly are added, and the task assigned to the design engineer. As before, the project leader adds an attachment, but this time it's the 3D markup of the orbital sprinkler. To add the new sprinkler design to the task as a deliverable, the project leader searches the platform for the Revision B model using the simple but powerful search tools, filtering the results using the 6W tags to get only the models in the frozen maturity state. Once added, the task creation is complete and ready to be picked up by the design engineer. Let's summarize what was shown and the benefits. With 3D markup, you can improve the communication of feedback in design reviews. We saw comparing the new revision with the previous one allows you to quickly get insight into design changes. And searching the platform is simple, fast, and precise. In the final demo, we'll look at how the design engineer can view the 3D markup created by the project leader, how the maturity graph is depicted in the release process, and how to access the derived step files related to the model. As before, the design engineer can access all his tasks directly through the 3DEXPERIENCE integration in SOLIDWORKS. With the task in the in-work state and open, the design engineer opens a markup from the attachment list. The 3DEXPERIENCE integration opens the 3D markup app in a web browser, allowing the design engineer to view the slides and the text notes added by the project leader. Next, the Revision B SOLIDWORKS orbital sprinkler assembly is opened from the deliverable section of the task. Once open, we'll change the maturity to released. This time, as only the top-level assembly selected, the maturity graph is shown instead of a list. We can ensure that all the required child components are also released by using the option Include Structural Objects. The 5 states in the maturity graph for engineering objects like CAD files are private, in work, frozen, released, and obsolete. When completed, the new revisions are marked as released. In collaborative tasks, the design engineer completes the task by selecting the check mark. Now that the design is released, the design engineer wants to get the revised base part over to a supplier. But instead of sending them the native SOLIDWORKS model, a step file should be sent instead. The step file, created by the SOLIDWORKS connector, lives in the platform as a related derived output to the model. It can be accessed by navigating to the base part in the Product Structure Explorer app and then its 3D shape object. Once the 3D shape object is selected, the side panel can be used to show information on that object. The step file can be located and downloaded from the Derived Outputs tab. Let's summarize what was shown in the benefits. Easily viewing team members' feedback improves collaboration. The pre-configured maturity workflows can simplify the approval process. And derived formats automate tasks for downstream use, freeing up time. The 3DEXPERIENCE platform allows you to securely centralize your data, improve collaboration, and design concurrently, all in the cloud, while maintaining your design tool of choice, SOLIDWORKS. This introduction showed only some of the platform's data management capabilities. Connecting to the platform, design teams are always in sync, and with a seamless integration, you can store and manage SOLIDWORKS data in the cloud, enabling collaborative working wherever you are.